All right, so we're on 8.1's notes right here. If you didn't get this down yesterday, or if we neglected to do it in class, one or the other, go ahead and copy down that information. Sorry about that there. Okay, for the names of the polygons. A three-sided shape, three sides means a triangle, four sides quadrilateral, five sides pentagon, six sides hexagon, seven sides heptagon, eight sides octagon, nine sides nonagon, 10 sides decagon. These shapes here you are responsible for knowing the names of and knowing how many sides that corresponds with that name. And like we talked about, is that for this class, if a shape has 11 or more sides to it, we just refer to those shapes as based upon the number of sides it has. So if a shape has 11 sides, we will call that an 11gon. Shape has 12 sides, we call that a 12gon. Shape has 13 sides, we call that a 13gon. Okay? And et cetera, et cetera. So, but please don't translate that to thinking it's okay to, for example, refer to an eight-sided shape as a eightgon. You have to refer to an eight-sided shape as an octagon. Now, we're going to go over here to this table right here where it says titled Sides, Triangles, and Sum of Interior Angles. Okay, off to the left of the table in this second row, please title this Number of Triangles. And the third row, we are going to title this Sum. Where does sum right there? Didn't come out very clearly. We're going to title it Sum, S-U-M, not S-O-M-E. Sum like we're adding everything up. Sum of all interior angles. Okay, and we're going to build upon what we talked about previously in class. So here's what we learned yesterday, that when a shape has three sides, the number of triangles is 1. When a shape has four sides, the number of triangles that we were able to create was 2 triangles inside that four-sided shape. When a shape had 5 sides, the number of triangles we were able to create inside that 5-sided shape was 3 triangles. A 6-sided shape, we were able to create 4 triangles inside that 6-sided shape. A 7-sided shape, we were able to create 5 triangles inside that 7-sided shape. 8 sides, 6 triangles. 9 sides, 7 triangles. We did all of this in the previous class, and we did not do a 10-sided, but if you notice, the number of triangles is always 2 less than the number of sides. So if we have a 10-sided shape, that means that we are going to be able to create 8 triangles inside that 10-sided shape. Now, this last column here, which says n sides, n means we don't know how many sides a shape has. This is like a general formula. But we do know that the number of triangles is always 2 less. So if there are n sides, that means there is going to be n minus 2 triangles that we could create inside that n-sided shape right there. Okay? And then this last row, where it is titled Sum of all the interior angles, this is what we do. We know that when we talk about triangles, we know that the triangles, the angles always add up to 180 degrees, right? Remember. Okay, so that means if we have one triangle And if triangles always add up to 180 degrees, that means that the sum of the interior angles is going to be 1 times 180, which is 180 degrees. So a three-sided shape, the angles on the inside of the shape, that's why they're equal to 180 degrees. When I have a four-sided shape, I was able to create two triangles. Two triangles times 180. Every triangle is 180 degrees. That means that the sum of the inside, the interior angles of a four-sided shape is 360 degrees. Okay. Now what we're saying is that all the angles inside a four-sided shape will add up to 360 degrees. Remember, sum, S-U-M, means we're adding up all the interior angles. Okay, a five-sided shape, we were able to create three triangles. Three triangles times 180 degrees per triangle is 540 degrees. So that means when a shape has five sides, known as a pentagon, that means that pentagon's angles, all the angles on the inside, are going to add up. They're going to have a sum of 540 degrees. You guys getting this? Say yes, say no. Heard a lot of yeses. I heard a lot of nothing, actually. Okay, six sides. That means we have a hexagon. We were able to make four triangles inside that six-sided shape. Four triangles times 180 degrees is equal to 720 degrees. So that means that when you have a six-sided shape, a hexagon, all the angles inside that six-sided shape will have a sum of 720 degrees. Okay, a seven-sided shape, known as a heptagon, we were able to create five triangles. Five triangles times 180 degrees gives me 900 degrees. So that means all the angles in a seven-sided shape, a heptagon, will have a sum of 900 degrees. Okay, eight sides, an octagon. I was able to create six triangles inside that eight-sided shape, that octagon. Six triangles times 180 degrees is 1,080 degrees. So that tells me that all the angles inside an octagon, an eight-sided shape, will have a sum of 1,080 degrees. Okay, a nine-sided shape, a nonagon. I was able to create seven triangles. Seven triangles times 180 degrees gives me a total of 1,260 degrees. So that means that all of the interior angles of a nine-sided shape, a nonagon, will have a sum. That means they'll all add up to 1,260 degrees. Okay, and then the 10-sided shape gave me eight triangles on the inside. Eight triangles times 180 degrees gives me a total of 1,440 degrees. Okay, and that means that whenever I have a 10-sided shape, a decagon, that means all of the interior angles will have a sum of 1,440 degrees. Okay, so this leads us to our formula, which is if we have n sides. And this is going to bring us to down here in our notes where we have formula for finding the sum of the interior angles for any polygon. Okay, and I'm going to give you two formulas actually. The first one is going to be for the sum of all interior angles. And the second formula that I'm going to give you is going to be for the measure of each interior angle. Okay. Measure of each interior angle. Okay, so let's go to the first formula, the sum of all the interior angles. Okay, so what do? How do we find it? Let's go back to our chart here. We take the number of triangles. Let's go to this last column when we had n sides. We take the number of triangles, which is n minus 2, and then we multiply that with 180 degrees. That's the formula to find the sum of all interior angles. It's n minus 2 in parentheses multiplied with 180 degrees. Okay, now you have to know what n stands for. What does n stand for in this formula? N stands for the number of sides of the shape. Okay, so essentially, if you want to find the sum of all the interior angles of any polygon, any shape that has 3 or more sides, you take the number of sides, n, minus 2 from that, and then multiply that with 180 degrees. Okay, now, if you want to find the measure of each interior angle, so this means if I want to find just one of the interior angles, this is what I do. I use the same formula, n minus 2 in parentheses times 180, but what I do is I divide it by n. So the n minus 2 times 180 part of the formula tells me the sum of all the interior angles. And if I want to know how many degrees each interior angle is, then I divide by n. And just like in the previous formula, n stands for the number of sides of the shape. Okay, so let's go ahead and let's do a couple examples of this. All right, example number 1, let's say I have this shape. 1, 2, 3. Go ahead and draw the shape. I'm drawing a 6-sided shape. So this is what is known as a hexagon. Okay, we already know that though. Hexagon known as 6 sides. And here's what we're going to find. We're going to find the sum of the interior angles. And after we find the sum of the interior angles, we're going to find the measure of each interior angle. So there's 2 things we're going to do in this problem. Find the sum of the interior angles. That means we're going to find the sum of all of them. And then the second thing that we're going to do is then we're going to find the measure of each interior angle there. Okay, so how do we find the sum? So first of all, we have to know what n is. Okay, so in this problem, in this example, what's n? Well, n is equal to 6. Why 6? There's 1, 2, 3, 4, 5, 6. So to find the sum of the interior angles, I take n, which is 6. I minus 2 from it, 6 minus 2, and then I times that with 180 degrees. Okay? That becomes 6 minus 2 is 4. I times that with 180 degrees, and that's equal to 720 degrees. So the sum of all the interior angles is 720 degrees. Okay, now, to find the measure of each interior angle, I take that 720 degrees, which I just got. And how did I get that 720 degrees? I went 6 minus 2 times 180 degrees. But now I'm going to divide that by 6. By 6. Why am I dividing by 6? Because the formula to find the measure of each interior angle is n minus 2 times 180 divided by n. N is the number of sides, 6. That's 120 degrees. So each angle is 120 degrees. So here's what I found out. If you're having trouble like comprehending this, I just found out that each angle inside this hexagon is going to be 120 degrees. And if I add them all up, if I add up all the 120s, they will add up to a total of 720 degrees. Okay, hopefully this is making sense what we're doing here. All right, so that right there would be example number 1 of what we're doing. Let's do another example. Example number 2. And in this example here, what we're going to do is we are going to write an equation. Okay, and then we are going to find the value of x in the problem. All right, and in this problem, I'm going to go ahead and do a hexagon again, just because we just did it. But this problem is going to be a little bit different in that what we're doing in example 2 is we're going to find the value of x. So this angle up here at the upper left is represented by x degrees. And then I'm going to give you the measurement of each one of the other individual angles in this hexagon here. So we have 130, we have 100, we have 120 degrees down here, the bottom right. At the bottom left, we have a 150 degree angle. And then in that middle left, we have a 95 degree angle. Okay, and what I'm going to do is I'm going to find the value of x in this problem here. Now, x is the unknown interior angle. Now, notice all of the angles are not the same. So we don't have this situation where we have 120, 120, 120, 120. So we can't use the measure of each interior angle, but we can use the sum of all interior angles. Okay, notice in this problem that n is equal to 6 again. Why is n equal to 6? N stands for the number of sides. So here's what I'm going to do. I'm going to find out how much all of these angles are going to add up to. Okay, so I'm going to take 6 minus 2. I'm going to times that with 180 degrees. I'm using the n minus 2 times 180 degree formula. Okay, that would be 4 times, we've already done this, but let's do it again. That would be 4 times 180 degrees. So that is 720 degrees. Okay, that's not your answer. But that we need that for our answer. Here's why. So what we're going to do now is, so this tells us that all of these angles on the inside will add up to 720 degrees. So in other words, the angle where the x is, plus the 130 degree angle, plus the 100 degree angle, plus the 120 degree angle, plus the 150 degree angle, plus the 95 degree angle. All 6 of those angles will have a sum of 720 degrees. That's what that n minus 2, that 6 minus 2 times 180 degree formula tells me. And what I do is I use this equation by combining all of these like terms together to help me figure out the value for x. So let's combine the 130 with the 100, with the 120, with the 150, with the 95, all of those angles combine to 595. So this means my equation becomes x plus 595 is equal to 720 degrees. And I subtract 595 from both sides of the equation. And then this allows me to know how many degrees my x is. Okay, 720 minus 595 gives me 125 degrees. So in example number 2, the value of x is 125 degrees. Okay, and I did that by, first of all, using the n minus 2 times 180 degree formula, which is to find the sum of all the interior angles. And then after that, I wrote an equation adding up all of the angles on the inside of the shape, and I set it equal to my sum, which was 720. Then I solved it for 25, or for x, which was 125. Well, now let's move on to the notes for section 8.2. So in section 8.2, we shift from angles on the inside to angles on the outside. In other words, exterior angles for polygons. So we're still talking about polygons, okay? But now, like I said, we're shifting to angles on the exterior. So first of all, how do you make an exterior angle? Let's go ahead and draw a couple shapes here. Let's draw a pentagon, 5-sided shape. Let's draw an octagon, an 8-sided shape. One, 2, 3, 4, 5, 6, 7, 8. And let's go ahead and draw, let's do a heptagon, a 7-sided shape. I'm not very good at drawing heptagons, so hope for the best here. Okay, not great, that's okay. All right, so how do you make exterior angles? So we've got interior angles, and the interior angles would be all the angles where the red dots are. So in every one of these shapes here, the red dots indicate that each one of that indicate an interior angle. Okay, but in 8.2, we're talking about exterior angles, angles on the outside. And here's how you make exterior angles. What you do is you take a side of the shape, and it doesn't matter which side you start at, but you have to start at a side. And you just take the side of the shape, and you just extend that side of the shape, so it goes outside the shape. And what you do is you just go around the shape, taking a side of the shape. Just work your way around the shape in a clockwise manner, and always extend each one of the sides going outside the shape. Okay, you just work your way around the shape going in a clockwise manner. And then what you find out and what you have done is you just made the exterior angles for that particular polygon. And the angle that I am numbering off with the number 1 in each one of those, each one of these spots, all of those angles are all exterior angles. Okay, so all of the 1s, those are exterior angles. Okay. All of the dots, all of those, every angle where there's a dot, those are interior angles. All right. And if you notice, the exterior angles, they're all outside the shape. All right. So if I were to go over here to the octagon, let's make the exterior angles for each one of the side. So I'm just going to take a side, start at it, and extend that side. So I'm starting at the top. Extend that side outside the shape. And then just go around the shape in a clockwise manner and extend each one of the sides outside the shape. And when you do that, you will have created all the exterior angles for that shape. Okay, and the cool thing about this is that if we went around the shape in a counterclockwise manner, we would still get all the exterior angles. They would just be on the other side. So now, once again, all of the angles where I put a 1 in, all of those are going to be the exterior angles. So you can see we end up with 8 exterior angles, just like we ended up with 8 interior angles.
Lynn Henson, please report to the front office. Owen Henson, please report to the front office.
And if you notice, there's always an exterior angle side by side with an interior angle. Okay, that's pretty cool right there. Let's do one more. Okay, let's take each one of the sides of this 7-sided shape here, the heptagon, and let's just create the exterior angle. So start at a side, extend that side outside the shape, and then just keep doing that, working your way around the shape in a clockwise manner. Always extending the sides outside the shape. And each angle that is created by the side of the shape and the extension of the side of the shape will be what we call an exterior angle for the shape here. And once again, all of the angles that I just created, they're all outside the shape. So they're all exterior angles. All of the angles where I put the number 1, all of those are exterior angles. Okay, so that's how we make exterior angles in a shape. Okay, so now there are 2 formulas that you need to familiarize yourself with. They're pretty easy. Okay, the first one is really not a formula, it's a number. The exterior angles formula. Okay, and this is it. It's kind of nice because it's the same for every shape. So all polygons, exterior angles have a sum of 360 degrees. Period. End of story. Okay. So the exterior angles formula, it's not a formula. It's 360 degrees. Every single polygon, if you added up all the exterior angles, they all add up to have a sum of 360 degrees. Okay, that's super cool. All right, so watch this. Why is that important right here? Here's why. Here's where we would use this here. So here's my shape. 1, 2, 3, 4, 5. So I have a pentagon. Okay. And in this pentagon, I'm going to have 5 exterior angles. And I'm creating the 5 exterior angles right now. So this is how we create the exterior angles. Like that. All right. So let's say the angle up here at the upper left is 90 degrees. The next exterior angle is 65 degrees. The next exterior angle is X degrees. The next exterior angle, just going around clockwise, is 41 degrees. And that last exterior angle over here on the left is 76 degrees. 76 degrees. We can use the fact that no matter what type of polygon we're working with, all polygon exterior angles have a sum of 360 degrees. We can use that fact to figure out the value for X. Why? Here's why. That means that the angle where the X is on plus the 41 degree angle plus the 76 degree angle plus the 90 degree angle plus the 65-degree angle, all of those angles will add up to 360 degrees. Why 360? Because that's the formula. All the exterior angles are going to have a sum of 360 degrees. And I use this equation by combining these four like terms together, 41, 76, 90, and 65. Those combine to 272. So I use this equation to figure out what's going to be my value for x. So simplifying the equation, I get x plus 272 degrees is equal to 360 degrees. And then I minus 272 from both sides of the equation. And this tells me that my value for x for this particular problem is going to have to be 360 minus 272, which is 88 degrees. That's pretty cool right there, if you think about it. Okay? And then that brings us to our next example, which is, what is the formula for one exterior angle? So the one exterior angle formula, pretty easy formula. It's 360 degrees divided by n. And just like in the interior angle formula, n stands for the number of sides, okay, of the shape. So what does that mean? Here's what that means. Let's say I have an 8-sided shape. 1, 2, 3, 4, 5, 6, 7, 8. And I want to find out how much is one of the angles, just one of the angles of this octagon right here. Now in this problem, n is equal to 8. Why is n equal to 8? Because there's 1, 2, 3, 4, 5, 6, 7, 8 sides. So how do I find x? How do I find the measure of one exterior angle? I go 360 degrees, and then I divide it by n. N is 8, number of sides. And that's whatever that equals. 360 divided by 8 is 45. So that tells me that x is equal to 45 degrees. Okay, and that's how many degrees one of the exterior angles will be. Okay, so there are some formulas. There's actually 4 formulas I just gave you. 2 of them for exterior angles and 2 of them for interior angles. Study them, practice them, okay, and then that'll help you out with finding measurements of exterior angles and interior angles. So there we go, 8.1 and 8.2 notes.